Okay, guys, so today we're going to start with the beginning of our statistics course. This first chapter is kind of a light chapter, a lot of definitions, a lot of information, but not a lot of like calculation-based math. We won't start getting into calculations until chapter 2 and 3. So again, just kind of take good notes. Remember, pause the video so you can keep up. Sometimes if you don't want me to just tell you the answers, you should pause the video and try to see if you know what's going to happen. Sometimes I will ask you to pause the video, try it on your own. So, what you realistically should do is you should try to treat these videos as if you were listening to me in class, in lecture. The advantages, you can actually stop and catch up by pausing the video. The disadvantages, you can't ask me questions while I'm teaching. Because this is a pre-recorded video. So that's what you want to write down, maybe your questions, so then we can talk about them when we meet, okay? So to start, why don't you guys take a minute to read the definitions I have listed there: data, statistics, population, census, and sample. And then we're going to use that information to answer some of these questions below or categorize them, okay? So take a minute to read that, pause the video. Okay, so hopefully you guys are back from the pause. So what we'd like to do is we'd like to evaluate each situation and identify whether it is a population or a sample. So we have a sample. Oops, I like blue a little bit better. Let me use blue. We have a sample and we have a population. So a population is any complete collection of individuals, peoples, animals, plants, or things from which we may collect data. And a sample is a sub-collection of members from the population, okay? So what we're going to do is we're going to say American citizens. So the way there's a little bit of gray area in this, because technically are American citizens the population of the world? No. But for what we're probably looking at, they probably mean American citizens is the population we're going to work with. And then we're going to take a sample from the American citizen population. So American citizens kind of, how do I say this? In the theme or in the nature of how it's described is probably what we're going to call population. Marketing research for a new deodorant, that is obviously going to be a sample, right? Because marketing research for a new deodorant, it's only one particular type of deodorant. It's research taken from that, and that is a sample that they've taken from, the market of deodorants, okay? All registered voters. So the reason they said all is technically are registered voters the only people? No, there's people that are not registered voters. So the reason they say all registered voters is they want you to think of that as a population. So a lot of times when they use the word all, they want you to think of it as a population. People of North America, that sounds like a population again. Do you guys kind of see, hopefully, that there's a little bit of a gray area that we run into, because people of North America are not the only people that are in the world. So if you rephrase the question, North America could then be a sample of the entire world, but it really depends on how the question is worded. So we're just going to say people of North America, the way they say it, just straightforward like that. We're going to go with population. A Gallup poll, that's obviously a sample. A Gallup poll is just a name of a polling company. Sample. So then we have the world's population, or the world's births. Again, that's going to be a population. They're basically trying to tell you that it's everything that we're going to talk about. Population. And a survey of smoking habits of hypertensive patients. That's definitely a sample, because they're being very specific and talking about one specific part of a group. So it's smoking habits of just hypertensive patients versus non-hypertensive patients, or so there's all kinds of different things there could be, okay? So that's one way you can categorize population and sample, but there is a little bit of gray area on the wording, okay? So important features about samples: sample data must be collected in an appropriate way. This means that the sample must be obtained through random selection. If sample data are not collected in the appropriate way randomly, the data will not allow us to draw a conclusion. So this is a big mistake. So let's say that I handpicked 10 people and they all agreed with my viewpoint, and I could say, listen, I just talked to 10 of my students and all 10 of them agree that this should be the grade for the class, and that's what we're going to do because all 10 people said that. That's 100% success. Now the problem is I handpicked them. It was not random, so I lose all statistical credibility. Okay, so remember, even if the data is overwhelming, how was the data gathered? Even if 95% of the people agree with or disagree or whatever, how was the data gathered? So that's kind of what chapter 1 is a little bit informing you on. Now, again, I'm not going to go into every single one of these questions. Some of these I'm going to leave for you to answer, and that's what you're going to submit to me for your weekly videos. But in general, I will try to go through a lot of this with you. Okay, so a poll asked 1,000 American adults, do you agree that global warming is a phenomenon that occurred in is occurring with foreseeable consequences? So what is the sample? Well, I'm going to say the sample is the 1,000 American adults. Okay, what is the population of interest? All American adults. So pretty straightforward, right? We see that there was 1,000 Americans that were in our sample, but it was taken from all American adults, okay? By the way, the numbering in these, see how this says 1.1? This is from the old edition of the book. This is from the 5th edition of Triola. We are now on the 7th, and the 13th is like a special weird edition just for certain colleges. But I think they're on the 7th or 8th edition right now currently. So this is an older edition. And with the older edition, the 1.1, 2.1, 3.1 sections are like half a page in your book. So they're very minor. So what the new editions did is they included them. So a lot of times, you guys, the numbering will be off by 1. So technically, now that I'm doing 1.2, 1.2 is what will actually be 1.1 in your book, in your homework, okay? So just keep that in mind. It's all the same information, but don't let it throw you off too much in the notes, okay? Versus the notes versus the videos and stuff and homework, okay? You should be able to line it up eventually, okay? So it says, during statistical analysis, we must consider the following factors: context, source of the data, sampling method, graph the data, explore the data, apply statistical methods, and then statistical significance. So these are all things that we're going to talk about throughout the course. So one of the things that I really want to focus in on here is statistical significance. Do the results have statistical significance and or practical significance? So here's something important. Statistical significance, significance achieved in a study when a result is very unlikely to occur by chance based on probability, okay? So basically saying there's no way that really could have happened, you know, it's not just luck, you know, or chance that happened. There is something to this. That's what statistical significance means. Practical significance means what the results mean in the real world. It is possible that the treatment of finding is effective, but common sense may suggest that it does not make enough of a difference to justify use. So, you know, let's just say, for example, I'm like a big guy, I'm like 280, I'm 6'5", 280. So let's say I wanted to go on a diet and I wanted to lose weight. And I tried 2 different diets for a year. I tried one diet for 1 year and another diet for another year. So the first diet I went on, or let's say 6 months. So for the first diet I went on, I lost 2 pounds in 6 months, okay? And then for the next diet I went on, I lost 25 pounds in 6 months, okay? Now, let's say that there were 100 people that went on diet A, okay? So diet A, we had 100 people, and we all lost about 1 to 2 pounds over that 6-month period. Almost every single person lost 1 to 2 pounds. So it seems to me that everybody in that study, we all lost 1 to 2 pounds. Everybody lost a little bit of weight. So is it likely statistical luck or chance that we all lost 1 to 2 pounds? Or is it likely that the diet did something to help us change our weight by 1 to 2 pounds over that 6-month period? I would say if all of us lost, you know, an overwhelming number of us lost, and we did a study on it and we proved that it was a valid study and everything, and we all lost weight, I would say that it's unlikely that all of us lost weight by chance. The diet that we were on must have contributed in some, you know, way. So that would have statistical significance. However, what about the fact that I took 6 months to lose 1 or 2 pounds? Is that practical? Let's say that the diet costs $400 a week or $400 a month to maintain. Is it worth it? Is it practically significant to lose 1 to 2 pounds over 6 months You know, maybe not, you know, so that's where you would have to decide what is practical for that. So normally it's pretty obvious when it's practically significant versus not. That's something that is more than likely not statistically significant. I mean, that is statistically significant, but it wasn't really practical to spend that amount of money or something like that. Okay. So statistical significance means that it's unlikely that it occurred by chance. It's very unlikely that all of us lost weight. The diet must have done something. However, it probably, you know, it probably wasn't worth the money or worth 6 months of my life to, you know, go on a diet that, you know, was maybe really hard or whatever. Now, let's say we did the next diet, B, and let's say that I lost, you know, a half a pound over 6 months. Another person gained a pound. Another person lost a half a pound like me. But some people had no weight gain, no weight loss. Some people did. Is it possible that that could have just happened by chance and this other diet we were on had nothing to do with it? Is it possible that we just, you know, all kind of did our own thing and the diet really didn't affect us? So that would not have statistical significance because it can't be proven that it couldn't have just happened by chance. So, you know, like tomorrow, if I wake up, I might weigh 1 pound less than I did today. You know, that to me doesn't seem like statistically significant. Now, if, you know, 100 people do something and they wake up and weigh a certain amount less each time, or 1,000 people or 10,000 people, and we all have similar results, maybe that is more statistically significant. I don't want to talk too much on it. It sounds like I'm opening up a can of worms. I could see how there could be other avenues we could go down. So I don't want to go too crazy onto that. Okay. So take a minute to read these: misleading conclusions, self-reported results, small samples, loaded questions, order of questions, non-response, missing data, precise numbers, and percentages. And we'll kind of go over these right now, okay? So just take a minute, you know, and kind of read through some of these right here, and then we're gonna talk about them, okay? All right, so hopefully you guys are back. So this first one says, when stating a conclusion based on statistical analysis, we should make statements that are clear and use terminology that everyone can understand. We must also avoid making statements not justified by the statistical analysis. So it says there's a very strong, oh no, hold on real quick. This is what's in yellow here. When a association or correlation is found between two variables, it simply shows that the two variables share a relationship. It should not be concluded that one variable causes the other variable. Just because two variables are correlated, it does not imply causality. Correlation does not imply causation. This is very important, okay? So it says here's this example. There's a very strong correlation between shoe size and reading scores. As shoe size increases, reading score increase. Does that mean that having a bigger shoe size causes one to be a better reader? Absolutely not. However, there is a correlation. They're showing that as shoe size gets bigger, there is an increase in reading score. That doesn't mean one causes the other, right? So you got to really keep that in mind when you're reading these studies. You can't automatically make the jump that this is definitely causing that. That's one of the problems with statistics in general that people don't pay attention to, is they say, oh, well, this is the case. Well, then this must be everybody. This is happening to everybody like that. It doesn't mean that that was the determining factor. There could be, you know, a lot of things, especially with social things. It could be economic. It could be, you know, cultural. It could be all kinds of issues that are causing a problem. So just keep that in mind, that correlation does not imply causation, okay? Self-reported data. Moral of the story is people lie. If you collect data by allowing people to self-report it, the results are going to be distorted. Let's say we're going to do a study about weight. If people are allowed to simply tell the researcher what they weigh rather than being weighed, hold on, let me switch my page real quick. Rather than being weighed by the researcher, are the calculations and conclusions about weight going to be accurate? The answer is no. People, you know, will round off. They will say what they think their weight is. You know, most people don't know their exact weight at any given time. You know, I might be 279 today, or I might be 283. I'm not sure, but I know I'm around 280. But again, that's not a very accurate assessment. So what I should be doing is, if I was the researcher, I should weigh every person instead of letting them report it themselves. Small samples, conclusion based on samples far too small relative to the population of interest. will not be valid. I am interested in the average number of hours students at Southwestern College study per week, and I take a sample of 5 people. Will this conclusion be valid? Probably not. I think Southwestern College might have like 15 to 20,000 people enrolled in the school. So 5 does not give me a proper assessment for the entire school. Just like if you're doing data on the entire United States and you poll 50 people should not be enough to do the entire United States. So that's why normally they might do 50 people per community, or when they do polls, they might do thousands or tens of thousands across the country, just to try to keep those numbers up so they don't have such a small sample size. Loaded questions. When the questions on a survey are worded in such a way that they can be misleading, confusing, or worded to elicit a desired response, this leads to response bias. So it says, don't you think it is wrong that there's a proposal to put a new casino in Jamul that would cause massive traffic jams in the area and would have negative impact on natural wildlife? So think about this. First of all, they said, don't you think it's wrong? So they're already trying to get you to say that, okay? Then on top of that, they're telling you that the new casino in Jamul would automatically cause a traffic jam and would have a negative impact on natural wildlife in the area. So just so you know, they're automatically saying this is a fact. Okay, this would cause a massive traffic jam and have a negative impact on wildlife. By saying that, they're saying that it's already accepted that that's going to happen. You don't know exactly what's going to happen. And by the way, anytime you build something in where there was nothing before, I'm sure it's going to have an impact on wildlife. So in general, that's always going to be the case. If you put a building somewhere, there was probably something living there that you are now moving. So in general, that's always going to be the case. So massive traffic jam in the area and negative impact on wildlife are how they're trying to force you to follow their response that they want. So a lot of times this happens. You guys have to look out for this on surveys and things like that. Order of questions. Oftentimes people choose whatever option they hear first. So thus the ordering of questions on surveys can be randomized so that the order of questions is not a factor in the results of the survey. So what if they have a question that they don't really want you to pay attention to, and there's 50 questions on the survey? They're going to put that one last. That way, most people won't really read it because they're tired of reading 50 questions. So they do this all the time. This is a legitimate thing people do to get their desired responses. If they have something that you want to kind of just read the headline on and not actually read the fine print, they'll do that as well. So you just read the top, but you don't actually read the story behind it. That's not necessarily order of questions, but the idea behind it is similar. Okay, so non-response occurs when someone either refuses to respond or is unavailable. People who refuse to talk to pollsters are likely to be different in some way from those that do not. So there's a certain type of person that talks to a polling service and a certain type of person that won't. So the results of the poll are thus skewed because the information from the people who refused is not being represented. Okay, so if people refuse to answer the poll, then their opinion isn't counted, and only the people that answered the poll, their opinion is counted. So that can cause kind of a bias and be misleading. I'm pretty sure that happens in politics all the time, as you guys can see. So it just depends on how people abuse the statistics or I guess the type of argument or the way the data is gathered. People don't normally read the fine print and ask what was really being done. I think there was something, recently that talked about the coronavirus. And if you look at California, California has some of the largest numbers of coronavirus in the country. But they fail to mention that California is one of the most densely populated states in the entire United States. So yes, we may have the most, but we also have the most people. Okay, so but nobody cares to bring that up. Okay, so they just want to say, hey, California is horrible. We have the most cases. You got to pay attention. You got to think about stuff analytically, so people don't fool you. That's kind of your job, as the future, is to kind of think about things and don't let people fool you. Okay. Let's see here, missing data. Sometimes sample data values are missing due to random factors, but some data are missing because of special factors. People with low incomes may not respond to questions about their income. It is well known that the US Census suffers from missing people, and the missing people are often those low income groups. And it goes to the fact that, do you really want to go, if you don't make a lot of money, you don't want to go brag to somebody or, fill out that you're not making a lot of money or maybe you're out of work. That's just not a fun topic. So that's not something you're going to want to represent on a piece of paper or on a document. Totally understandable. Again, you see that there is good reasons why sometimes people don't respond. Precise numbers. Just the numbers reported are precise does not mean that they are accurate. Everybody does this, or I shouldn't say everybody, but a lot of times people do this, sometimes even including myself. It's a mistake I make. I don't mean to do it. I want people to know I actually calculated their grade correctly. So I'll give them like 7 decimals of accuracy to kind of overemphasize, hey, I know your grade for sure is this amount. It's really a 65.72831,724. Just to kind of let them know that is their grade. So there are now 105,215,027 households in the United States. Because the number 105,215,027 people erroneously assume he must be really, hey, this must be very accurate because they got it down to one household. That figure may actually be an estimate, but because it's precise, people think it's exact. It would be better to state there are around 105 million. So you guys know they probably have no way to accurately say exactly how many houses are in the households are in the United States. So this is trying to appeal to the fact that it's so precise that you think it must be exact, when in reality it's not, and they're probably just approximating the extra 27 at the end. So like I said, 105 million would probably be a better way to approximate this. Percentages. Some studies cite misleading or unclear percentages. So a poll of 2,302 adults, 2,302 adults claimed that 14% said they have a tattoo. The problem is if you take out your calculator and you do 14% of 2,302, 2,302, you get 0.14 of 2,302, you get 322.28 people, okay? So that can't actually happen, okay? So they had to round up. Now, again, it's a small thing, but it's not actually correct. Okay, so they should include something that says they estimated, or it's estimated that 14% said they have a tattoo. Okay, so on to the next section. It says types of data. So individuals are objects described by data set. Individuals may be people, but it also may be animals, things that are involved in the experiment. Let me turn my page real quick. So some examples would be students, doctors, dogs, cars, so on and so on. Things like that could be our subjects, our individuals, okay? And then we have a variable, what your major is in college, right? Your income, that could be a variable. What type of dog, it could be breed. It could be the make of a car, so on and so on. Okay. Parameter is a numerical measurement describing some variable of a population, and a statistic is a numerical measurement describing some variable of a sample. What I always remember is parameter goes with population and statistic goes with sample. So P with P and S with S. Okay. So take a minute to look at this problem. It says before the San Diego mayoral election in 2005, 2,500 San Diegans were asked who they planned to vote for. And 41.5% of that group said they were going to vote for Donna Fry. In the actual election, Donna Fry received 46% of the popular vote. So take a minute, pause the video, and enter in what you think is the population and the parameter, and what you think the statistic is and the sample. Okay, so you guys have the value 41.5 is a statistic. Okay, and because it describes a numerical measurement from the sample. Remember, it says 2,500 San Diegans were asked who they plan to vote for. So right there, they're saying 2,500 of the San Diegans, that's a sample. And 41.5 of them said they would vote for Donna Fry. So that would be a statistic, goes with the sample. That means that the 46% that actually voted for her during the actual election, that's from the population, and that is a parameter, and it's a measurement from the population. Okay. All right, you guys. So now we have quantitative versus qualitative data. So quantitative numerical variables with data that consist of numbers representing counts, measurements, which arithmetic operations such as adding and averaging make sense. So basically, you know, when you're doing distances or money or things like that, you would want to use, or you have quantitative variables. And categorical, or like, you know, phone numbers or zip codes, or you know, all kinds of things. What type of animal, what your major is, you know, anything like that. So let me write out some of these. So this could be your grade percentage. We could talk about your income. We could talk about your weight. You know, that could also be your height as well, so on and so on. Examples of categorical would be zip code. Let's see here, major. You know how they have like a number next to your major. Breed of dog or cat, I guess. Make of car, so on and so on, okay? Discrete variables have data whose possible values are either finite or countable, and continuous variables have data whose values are infinite in possibility that correspond to some scale that covers a range of values without gaps, interruptions, or jumps. Okay, so this is kind of a one that students have a lot of difficulty with sometimes. It's pretty nice, but I do see the little bit of confusion that can be caused. So a discrete variable have data whose possible values are either finite or countable. So it says the number of eggs a hen lays is a, and we're going to say this is a discrete. Oops. This is a discrete variable, because if a hen lays 5 eggs, no matter how you rearrange them or look at them or whatever, it's 5. A hen has to lay 5, 2, 1, 7, 20. They're always going to be countable. And it doesn't matter if you have a better measuring tool. It's always going to be, you know, a certain number, a finite number. The amount of milk a cow produces is called continuous. Okay, and the reason this is a continuous, I'll write it all out for the first few times, is it's not restricted to a discrete number of gallons. For example, it could take an amount of 2.5116798 gallons. And what if somebody had an even better measuring tool? They'd have a different amount of gallons. And every person that comes up with a different measuring tool could have another amount of gallons. So it's not, it's continuous. Or if you measure a tree is a certain height, but if you get a better measuring tool, you'll have a more accurate measurement, so on and so on and so on. So continuous is kind of that, the way I help myself memorize it is I think of it as, if I had a better measuring tool, would my height change, or would this number change? But if I had a better numbering tool and the hen laid 5 eggs, is there any other way I can cut it, or is it 5 eggs? So that's kind of how I separate in my mind discrete versus continuous. Okay, so let's see here. Let's go on to the next one. Did I skip a section? Oh, no, I'm okay. I just have a page that is repeated. Sorry about that. In my notes. Okay, so we have levels of measurement. So it says, in addition to be classified as quantitative, then either discrete or continuous, or qualitative, data can also be classified into one of 4 levels of measurement: nominal, ordinal, interval, or ratio. Okay. In general, I would say that categorical is normally used for categorical, and ordinal are normally, let me write this better. So those are normally measurements for categorical, and this would be for quantitative. Okay. So nominal data consists of names, labels, or categories only. The data cannot be arranged in any order from low to high. So for example, eye color is the one they use because You know, you could have brown eyes or blue eyes or green eyes or, you know, whatever. And it doesn't really matter how you arrange them. It's just eye color. There's no better or worse, you know, whatever. Now, ordinal is data that can be arranged in order, but differences between data values cannot be determined or are meaningless. So we know that the level, a grade of A is better than F, but we don't know how much better. If I told one student that they had an A and another student had a C, you know, I don't know exactly what's the difference between, you know, how far apart that A from that C was, okay? However, what I do know is that the A was better than the C. I think you could also use like, you know, movie ratings, you know, when you look on Rotten Tomatoes, and if they say, you know, the movie scored a 76% and this movie scored a 50%, you know that one movie is rated higher than the other, but what was better? Like, how do you calculate the betterness per se, so to say, from one movie to another? So it really is, you know, there's a difference, but it's hard to calculate that difference. So that's normally what ordinal is. Nominal means there's, you know, there's a difference and you can't really arrange them in any order, okay? But ordinal, you can arrange in an order. You know when this order works and one is better than the other, or, you know, worse than the other or whatever, but you can't calculate the differences, okay? So then we get to interval. Data can be arranged in order, but the differences between any two data values is meaningful. But there is no natural zero starting point. So the big thing is the natural zero. This has no natural zero and this does, okay? So that's the difference, the main difference between interval and ratio. Okay, so data can be arranged in order, different blah, 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 blah. So for example, the year. So, you know, the year 2000 and the year 2020. We know that there's a 20-year difference between that. We know that the years go in order, so they can be arranged. But the problem is if we go to 0 years, that's not actually the beginning of time, right? There's years before year 0, right? So years is something that we can arrange in order. We can do calculations from one year to the next. We can subtract or add and see how far apart the years were. So it makes sense. And the difference between any two data values is meaningful, so we can make sense of that. But there isn't a natural zero, the idea of nothingness, okay? It goes similar for temperature, okay? So right here, we have temperature in Fahrenheit. I'm gonna answer this question right here. Think of 0. If I say 0 degrees Fahrenheit, does that mean that there is no temperature, or does that just mean 0 degrees? And then we go negative after that. So that's what they mean by natural zero versus no natural zero. Temperature does not have a natural zero. Now, that's in Fahrenheit. In Celsius, I had one student talk to me about it, and it actually, you know, if you have 0 degrees Celsius, are you saying that it's a lack, there is no temperature? So Celsius might be different, but if you're talking Fahrenheit, 0 is not natural, there is below 0. So this would be called interval, okay? Now ratio is all of those things, but it actually does have 0 as the natural 0. So like if you say, you know, how much something costs you at a store or whatever, it's going to be anywhere between $0 and you're not going to get negative money back. You know, it's going to be $0 to, you know, whatever the price is. So that would be price of college textbooks. I would think price of college textbooks would be ratio because there is a natural 0, okay? And you can tell the difference between one textbook and another by price. It makes sense, right? One is $60, one is $50. There's a $10 difference. So it makes sense. A lot of times I think of it as, you know, addition and subtraction and things like that makes sense, okay? Class ranking. Class ranking would be ordinal. Okay, class ranking would be ordinal because what rank you are in the class, if you're rank 1 and I'm rank 2, I know that you're a higher rank than I. I know there's a difference and we can be arranged in order, but I don't know how much better rank 1 is than rank 2. How much more do you understand about statistics than I do because you're rank 1 and I'm rank 2? I know that you understand more, but how much, that's the thing. So that's what makes it ordinal, okay? And then political party is the easiest one, nominal. Okay, so there'll be quite a few little questions like this in the homework, and you just got to categorize them. You know, not too bad, pretty straightforward. Okay, let's see how much I have left here. few pages left. Some of it I'm gonna skip. I'm not gonna go into detail and everything. I'll allow you guys to read some of it and talk to me about it. So basics of collecting data, we have observational study and we have an experiment. We're not going to go too crazy into this because this will kind of come up throughout the course, but I'll leave you guys to read some of this. If you have any questions about it, please let me know. Now this is random sample versus simple random sample. A simple random sample is more, I shouldn't say more, a simple random sample is stronger than a random sample, but for our class, we're going to kind of treat them the same. So members from a population or members from the population are selected in such a way that each individual member has an equal chance of being selected in the sample. A simple random sample, the sample of n subjects is selected in such a way that every possible sample of size n has the same chance of being chosen. So a random sample is a weaker requirement than a simple random sample, but we will consider the two interchangeable for this course in this textbook, okay? So don't get too caught up on that. Basically, let's just kind of treat them the same. If it comes up and it's a big deal, we'll spend more time on it, but this video is already getting too long. We can talk about that in class if you'd like. So there's a few that I want to talk about. Let me see how much we have here. Yeah, I'm not going to talk about some of these ending ones, so I'll talk about these. I'll spend a little more time on these. Okay, so we have types of sampling. We have stratified sampling, cluster sampling, and systematic sampling. Those will be kind of the main three that I'll talk about. For this, you can read the notes on the rest and kind of do your best to talk about them or read the book and take notes on it. But the main ones that I want to talk about are the ones that I see people kind of mess up on that aren't as straightforward. So stratified sampling is we subdivide the population into at least two subgroups or strata so that the subjects within each subgroup share similar characteristics, age, group, geographical region, etc. A random sample is taken from each subgroup or stratum, and then these smaller samples are combined to form an entire sample. So it says, suppose you were studying the cost of living in San Diego and wanted to sample 1,000 homes. Just a simple random sample of homes in San Diego may render by chance homes only in East County, which is not representative of all of San Diego County. How could you divide San Diego into geographic regions or stratas? So what I'm going to do is I'm going to kind of take San Diego County. And what I'm going to do is I'm going to subdivide it, okay? I'm going to do the South Bay over here. Let's do East County. Let's do Central. Let's do Coastal. And let's do North County. Okay, so me personally, I'm from the South Bay. Some of you may be from East County, or a lot of you may be from East County. But what we're gonna do is we want everybody to be represented, okay? So what could we do to make sure that we have 1,000 homes sampled? We're still gonna be random, but we wanna make sure that everybody gets a voice in our sample. So what we're gonna do is we're gonna take 200 people from here, 200 people from here, 200 people from here, or 200 households, and 200 from here. So what we're doing now is understand that we are not, how do I say this? I don't want to confuse anything. So we are taking from each one of these 200, they are going to be randomly chosen. So we're going to call 200 people randomly chosen in the South Bay. We're going to, interview or survey 200 people in East County, 200 in Central, 200 in Coastal, 200 in North County. Now, technically, it wasn't random in one sense because we chose 200 from each. But of those 200, each of those was randomly chosen, right? So we are still preserving the integrity of the study by making sure that everything is random. But this way, everybody gets chosen. What they're saying is what if you did 1,000 people and just by weird luck, you only, just weird chance, that you got almost everybody from North County and Coastal. Well, then that means the people from the South County or from South Bay and East County, they don't get represented, or from Central, they don't get represented by this data. So this guarantees, by creating stratified sampling, this guarantees that all communities will be represented. And we're still preserving randomness by taking 200 from each locale. So this is a really good way that you can deal with this. It's actually a pretty good strategy if you think about it. So here's the thing, from each of the strata, we randomly sample the same. So we're doing random sampling of the same number of homes and then combine it for our 1,000, okay? So that's different than cluster, okay? So cluster does something different. The population is divided into sections or clusters, where each cluster is a heterogeneous group. We then randomly select some of those clusters and measure all of the individuals within those clusters, okay? So it says, to measure customer satisfaction, airlines often randomly sample a set of flights, let's say 10, serving as clusters from a possible 200 flights, and they distribute a survey to every person on the flight. So let's say, you know, and I can't draw a plane, so I'm just gonna pretend this is a plane. Let's pretend that's a plane, right? Let's pretend there's another plane, okay? And we're gonna do this all the way up to 200 flights. Right, so 200 flights, 200 flights. Okay, so we have 200 flights, and we're gonna choose 10 of these flights. So we're gonna choose, let's say this one, we'll choose one in here somewhere, you know, and we choose 10 flights. Okay, however, we then survey everyone on those flights. Do you see the difference between this and stratified? Okay, so what stratified does is it covers everything. So you break everything into strata and you take the same amount from each strata, okay, but you randomly choose from every single one of them, okay? So there's gonna be 200 from South Bay, 200 from East County, 200 from Central, 200 from Coastal, 200 from North County. However, with cluster sampling, they're going to take a cluster, they're going to take 200 flights, right? So a population divided into sections, and then where each cluster is a group, and then we randomly select from those clusters. So we have 200 flights, okay? And then we're going to choose 10 from that group of 200, okay? But instead of taking a sample from each of those 10 flights, we're going to pull everybody, or we're going to survey everyone on those 10 flights. Okay, so these are the two that get confused a lot. It says stratified sampling and cluster sampling are often confused. Cluster sampling uses all members from a sample of clusters, whereas stratified sampling uses a sample of members from each strata. So this one, we use all the strata, but a random sample from each strata. In this one, we randomly select subgroups from the cluster, but we interview or poll or survey or whatever, all of those that we choose, okay? So it's very important that you understand the difference. This one takes everything and takes a sample from everything. This one does not. This takes certain groups and does everything from those groups, but some groups are left out. Like we didn't do this flight, we didn't do this flight or this flight. So there's 190 flights that we didn't actually sample. So they use it in this case, because if you just picked, you know, 10 without doing this, you know, if you did, how do I say this? I'm sure this is done for money purposes also, so they don't have to do every single one. So a lot of statistics is sometimes used to help corporations not have to do so much financial work to gather data. They can base it on statistics, and the mathematics does the work. So I'm assuming something like this for airlines, so you don't have to do all 200 flights. You can just do 10 and rely on the randomness of the 10 chosen, okay? Systematic sampling. A starting point is chosen at random, and then every kth term or every kth element is included in the sample. Choose individuals at regular intervals. It is necessary to know the whole population size from which your sample is being selected. The appropriate sampling interval, I, is then calculated by dividing the population size, N, by required the sample size. So this is a long story short. You kind of have to know everything you're dealing with. That way, when you divide it, it can be well represented. So it says, suppose you want to sample 8 houses from a street of 120, okay? So what we're gonna do is we're gonna take 120 houses and we're gonna divide it by 8. And we end up getting 15, okay? So we get 15. So that means what we're gonna do is every 15th house, we're going to interview, sample, take a poll, whatever the case may be. So what that means is the randomness comes from the starting point, okay? So even though it's organized in a way that you know it's gonna be every 15th house, until we randomly choose our starting point, we don't know which houses are gonna be interviewed. Or data gathered from those households. So this is still preserving the randomness by choosing the starting point at random. So the first house would be, let's see here. So it says if a random starting point of 14 is chosen, then what houses would be selected? So we have 14, then the second house would be 29, right? Then the third house would be 44, the fourth house would be 59, fifth house would be 74, sixth house would be 89, seventh house would be 104, and eighth house would be 119, okay? So that way we covered all of the houses that we wanted. We got our sample of 8 and we chose a random starting point. This is called systematic sampling, okay? Multi-stage sampling. So it says Southwestern College is interested in whether students prefer classes with some online component or no online component. To do so, the school first randomly selects 3 schools within the college campus, then from each of the schools, 2 departments, and then from each of the departments, 5 classes, and then from each of the 10, from each class, 10 students are chosen. How many students will end up being chosen? So we're gonna start off with Southwestern College as our population, okay? Then we're gonna go to 3 schools. And by schools, I think they mean like the English department. And then, the English department might have sub schools where they would call them their, creative writing, their rhetoric, maybe their poetry, depends. So we're going to say, or from MSc would be math, science, and engineering. And then from there, you would choose particular fields. So we're going to go 3 schools. Then from the 3 schools, we're going to go 6 departments. And then from those 6 departments, we're going to pick 30 classes. And then from those 30 classes, we're going to choose 5 students. Oops, hold on. I'm doing this kind of wrong. I'm actually telling you the answer as we go. Okay, so it says to do so, first randomly select 3 schools, right? Within the college campus. Then from each school, 2 departments. So if each of these schools right here, we pick 2 departments, that's going to be a total of 6 departments now, right? And then from those 6 departments, we're going to choose 5 classes. Well, 6 times 5 would be 30. So now I'm at 30 classes. And then from those 30 classes, I'm going to choose 10 students. Is that what it says? 10 students. So that means we're going to end up with 300 students. Okay. So that will end up being our sample size of 300 students from a population of Southwestern College, okay? So that is one way we can do multi-stage sampling. Let me see how much more of this I want to go on to. So we kind of talked about this voluntary sampling, convenient sampling. Convenient sampling is like, if I was standing outside my statistics course and I wanted to know what students think about math at Grossmont College or at Southwestern College, I would then only just stand outside my class and ask students for their opinion or their information or data because it's just outside my class. So it's convenient for me to do that. That's not really random, right? I'm particularly interviewing my students outside of my class. So that would be a convenience sampling. And voluntary response sampling, we already talked about. Under coverage, non-bias, you guys can read through that. Observational study. You guys can kind of read through that stuff. I'm not going to go too heavy into that. I guess we can talk about this, but I think I would like for you guys to try to fill this out on your own, to try to submit this when you do your notes. You know, for example, it says, what are the individuals, the people or things being studied in the experiment? In this problem, the blood pressure in 450 subjects. So you would put 450 subjects right here. Okay. And then the factors, diet and physical activity, right? It says the explanatory variable in an experiment. These are what researchers are modifying or controlling. So they're controlling the diet and they're controlling physical activity. Okay. And then I'd like you guys to kind of fill in the rest on your own time, kind of go through that and see if you could decipher that. Or not decipher, but see if you could answer the following questions right there. Control groups, replication, confounding. Confounding occurs in experiment when researchers are not able to distinguish among the effects or distinguish why the effects are different. A professor wishes to test the effect of his new attendance policy. Your grade will be lowered by 1 point for every class missed, and plans to compare the average number of missed classes this semester with this new policy with last semester with no policy. However, in comparison to last semester, this semester had mild weather, whereas last semester had many days with blizzards, with blizzard conditions, which may have caused school to be canceled or many people not make it to class. So you cannot distinguish between whether it's the new his new policy or it was the weather. So that's something that's confounding. Okay, is maybe it was his policy or maybe it was just the weather. So that's what we think of as confounding. Okay. Blinding, placebo, and placebo effect. So I want to talk a little bit about blinding. And so when a subject in a single blind or a subject in research or double blind does not know whether the subject is receiving the treatment or placebo in the experiment, I can assume they do this a lot for humane reasons. You know, what if you have an experimental drug that you know is really helping people and it's curing them? You know, and you're the researcher or you're the doctor that's prescribing it. That means that the people you're giving the placebo to are maybe not going to get healthy, and you know they could have some adverse effects, and the people that you are giving the treatment to are going to get healthy. So that could cause a little bit of, I guess, problems with gathering data, because you know we're human, and if you're a doctor you probably want to help people, so you're going to want to help people. So I could see the double blind where the researcher or the doctor does not know if they're giving you a placebo or the real thing. And a placebo is an inactive substance like sugar or distilled water or saline solution that is meant to appear the same as the treatment in appearance but should have no effect on measured outcome made on the subject. Placebo effect, when an untreated subject reports improvement in symptoms, may be real or imagined. So yeah, I think I was just reading an article on Epsom salt, and you know, people soaking in Epsom salt to help with injuries and things like that. And I believe the information I read said there was no actual like mass study done on this, but a lot of people swear by it. So what a lot of researchers say is that it's possible that it has a placebo effect. The people think it helps them, and so it actually might, because if it relieves stress, we know that stress can cause a lot of problems with us. So if we feel like our stress is being relieved, maybe that helps. So that could be one case of a placebo effect. Okay. So I'm going to go ahead and ask you guys to do this on your own. So this is something you will submit when you submit your notes. Okay, and we can talk about it in class if you'd like as well. Yeah. You know what, I'm gonna say on this one, we don't need to worry too much about this part right here. Don't worry about that. Block design, read on your own. Let me see how much more I want to do. The video is already getting pretty long. Match pairs we'll talk about later on. Yeah, I think that's going to be it for this video, guys. So read this following information on your own and do your best. It's not something I'm going to focus heavily on right now. Match pairs will come up later in the course. So it's important for you to read it and do your best to discuss it with me if you want at the end of our next class. But for now, I think I covered most of everything I want from chapter 1. When you guys go back and look at the homework, you'll see a lot of these type of problems here. You know, up here in the earlier sections of the video, like nominal, ordinal, and all of that, sample versus population. Okay, you guys, I'm going to go ahead and end the video. Thanks for watching, and you'll be able to find this on Canvas.